let's learn about the linear ODEs, which is another very important type of ODEs that we can encounter in many engineering applications. So actually linear it means it's linear in both the unknown function and its derivative. Okay, so for example, y prime, this is the first derivative, right? So y prime plus e to the x y is 2 times cosine x. So it's linear. It's y prime and y. There's no square term or cube term. So it's that's why it's linear in differential equation. Okay. What about this? Y prime plus e to the x times y equal 2 to the y squared cosine x. So we have y squared term, so which is nonlinear in that case. So you can compare those two and see the difference between linear and nonlinear in differential equation. So now you understand the linear equation and nonlinear equations. And on the other hand, linear ODEs consist of two types again. So homogeneous linear ODEs and non-homogeneous linear ODEs. Okay, before we move on, standard form of the linear ODEs is explicitly expressed in this form. Y prime plus p of x is only function of x, the coefficient function. This is coefficient function. Coefficient function is a function of x only times y equal r of x, and here r of x is called input to the system and y is output of the system. Okay, now we have the definition for homogeneous and non-homogeneous equations of the linear form. Okay, homogeneous is meaning that the input term r of x is 0. So homogeneous r of x is 0. That's what homogeneous really means. So right hand side, if you have linear terms on the left hand side, then right hand side is simply 0 since there is no input term, additional input term. So it's a homogeneous in that sense. And non-homogeneous, on the other hand, is r of x is not 0. Something's there. So right hand side is some function of x is there. In that case, we call it non-homogeneous equation. Let's move on to how to solve such a linear ODEs.